Imagine waking up to a world where everything feels just a little heavier. Your morning coffee weighs more in your hand. Your steps feel sluggish, and the news is buzzing with panic. Why? Because Earth itself is growing, its radius expanding by 1 centimeter every single second. At first, it's barely noticeable, but this tiny, relentless tick compounds into a cosmic catastrophe that could crack continents, amplify gravity, and even transform our planet into a black hole. This isn't just a wild sci-fi plot, it's a gripping thought experiment rooted in physics, astronomy, and cutting-edge data, blending vivid storytelling with hard science to spark awe and keep you glued to the screen. From crumbling cities to shimmering lunar rings, we're diving into the chaos of an expanding Earth, exploring how humanity might survive or fall in the face of such an unstoppable force. Welcome to our channel, where we unravel the universe's boldest what-ifs with unmatched depth and excitement. Let's watch our planet balloon and see if we can hold on. Let's start by dissecting the problem. What exactly happens if Earth's radius grows by 1 centimeter per second? Our planet's average radius is 6,371 kilometers, a colossal sphere of rock, metal, and water that's been stable for 4.5 billion years. In this scenario, we assume constant density. Earth's mix of iron core, silicate mantle, and thin crust stays proportional, so mass increases to match the expanding volume. Why this choice? If mass remained fixed, density would plummet, gravity would weaken, and our atmosphere might leak into space like a punctured balloon. Instead, constant density means mass scales with the cube of the radius, since volume grows as radius cubed, leading to a linear increase in surface gravity. 1 centimeter per second seems trivial, slower than a stroll, but the math escalates fast. In 1 hour, the radius jumps by 36 meters. In a day, it's nearly a kilometer. Simple calculations show it takes about 28 hours to add a full kilometer to Earth's radius, a change that starts subtle but turns catastrophic. The immediate fallout: you'd feel a faint tremor, like a global earthquake rippling through the crust. Infrastructure crumbles. GPS satellites, calibrated for precise orbits, drift off course. Crashing navigation systems. Power grids fail as cables, stretched across a swelling planet, snap like overstretched rubber bands. Buildings, roads, and undersea internet lines designed for a fixed-size Earth collapse, plunging cities into blackouts and isolating communities. Real parallels underscore this. The 2011 Tohoku earthquake, which shifted Earth's axis by 10 centimeters, caused $235 billion in damage and triggered tsunamis. Now imagine that disruption amplified globally. Every second, gravity creeps upward. In just 5 years, a 25% radius increase could boost surface gravity by 25%, making a 70-kilogram person feel like 88 kilograms, straining muscles, bones, and hearts. Ecosystems falter. Birds struggle to fly in denser air. Marine life faces crushing pressures at shallower depths, and plants wilt under heavier loads. Skeptics might argue that such rapid mass addition defies energy conservation, as no known mechanism could supply the required material. But this thought experiment, inspired by Einstein's relativity hypotheticals, focuses on outcomes, not causes. Much like pondering faster than light travel to probe physics limits, the urgency hits hard. Our interconnected world, from global trade to internet connectivity, unravels in hours, exposing how fragile our systems are when Earth itself turns against us. Pause and reflect. If your hometown started cracking apart tomorrow, where would you go? Drop your survival plan in the comments. Now, let's ground this in the current state of science to see how this scenario aligns with what we know about our planet and the cosmos. Earth isn't a frozen rock, it's dynamic, shaped by tectonic plates grinding at centimeters per year, volcanic eruptions spewing new land, and subtle mass shifts from melting ice caps. NASA's GRACE satellites, tracking gravitational changes since 2002, show how water redistribution tweaks Earth's mass distribution, but nothing approaches our scenario's relentless growth. Yet, cosmic analogies exist. The universe itself expands. Per Hubble's 1929 discovery that galaxies recede at 70 kilometers per second per megaparsec, a stretching of spacetime that faintly mirrors our Earth's ballooning. On X, science enthusiasts dive into similar hypotheticals, with one viral thread estimating that in 20 years, a doubled radius would octuple Earth's volume and double its gravity, reshaping life itself. Seismic data from networks like the Pacific Ring of Fire reveal how mere centimeter-scale shifts trigger quakes, and eruptions now imagine that amplified as the crust fractures within days. Per materials science studies showing granite fails at 0.1% strain. While no natural process adds mass, this fast gravimetric surveys confirm Earth's stability within parts per billion. Advances in geophysics, like neutrino tomography mapping the core, suggest theoretical phase transitions could alter planetary dynamics. For instance, mantle convection models, updated in 2024, show how internal heat drives plate motion, hinting at mechanisms that could hypothetically scale up. Submarines and spacecraft share DNA. NASA's underwater NEMO missions train astronauts in neutral buoyancy tanks, mimicking zero gravity, while submarine crews endure isolation akin to Mars missions, per a 2020 ESA report. Laser ranging to Apollo reflectors on the Moon, accurate 2 millimeters, tracks Earth's subtle wobbles, offering insights into orbital chaos our scenario predicts. Supercomputers crunch petabytes of seismic and gravitational data, simulating planetary stresses with precision that sets us apart from simplistic guesses. Addressing skepticism, no observed process fuels such growth. But historical theories like the expanding Earth hypothesis proposed by geologist Samuel Carey in the 1950s once suggested a smaller ancient Earth to explain continental drift backed by paleomagnetic data before plate tectonics prevailed. Though debunked by subduction evidence, it shows science evolves, and our scenario probes similar edges. Engagement hook. How would a 10% gravity hike change your daily routine? Tougher workouts or shorter jumps? Share below. Current tech. From Fusion Labs pulsing 500 terawatts to mimic core pressures to AI-driven climate models, illuminates Earth's fragility. A 2023 study on coral reefs, adapting to sea level rise over millennia, warns that rapid changes like our diluted oceans could collapse ecosystems, flooding coasts. This synergy of data paints a vivid picture. Tiny shifts ripple into chaos, but human ingenuity, from laser mapping to bioengineering, offers hope amid upheaval. Next, let's explore the future implications as Earth's growth reshapes reality over months, years, and decades. Within a week, the crust stretches, opening rifts wider than the Grand Canyon across continents. New land emerges millions of square kilometers, but at a cost. Roads buckle, pipelines burst, and global trade grinds to a halt as ports drift apart. Gravity's rise rewrites biology. Biomechanical studies on astronauts show bone loss in microgravity, but here, a 25% gravity increase by year 5 compresses spines, spikes blood pressure, and ages organs faster. Per medical models, ecosystems shift. Elephants might adapt with stronger limbs, but insects struggle against thicker air, and coral reefs drown as oceans spread thinner, dropping salinity and disrupting currents like the Gulf Stream. Climate simulations, factoring in expansion, predict chaotic weather. Hurricanes intensify, echoing 2024's record storms, while polar regions freeze as currents stall. Satellites plummet as orbits decay in stronger gravity. The ISS crashes within weeks, ending space programs. By year 40, with the radius tripled, Earth's mass could approach the Moon's Roche limit, shredding it into rings. Per planetary dynamics models, this is an exaggeration. Artemis program data shows water-based radiation shielding blocks 90% of cosmic rays. A tactic survivors could scale, while energy limits challenge mass addition. Fusion breakthroughs, like the National Ignition Facility's 2023 terawatt pulses, suggest workarounds by mid-century. Resources boom as new crust exposes rare minerals, fueling tech revolutions. Think quantum computers powered by expanded mantle deposits. But societal costs soar. Migrations surge as lands fracture, mirroring today's climate refugee crises, but amplified 1,000-fold. Some regions green from volcanic ash, but others bake in runaway greenhouse effects as heat traps thicken atmospheres. The wonder: stronger gravity could simulate stellar cores, sparking fusion advances, or foster extremophile ecosystems. Per astrobiology trends. Comment: would you mine new lands or build orbital refuges? This future blends peril with potential. pushing humanity to innovate geoengineering to cool the core, or space habitats to escape gravity's crush. Preempting doubt. Thermodynamic limits exist, but speculative physics, like Dirac's 1930s varying constants, once proposed balanced expansion, hinting at feasible futures. This vision drives progress, from sustainable tech to cosmic exploration, urging us to adapt or perish. Now, let's ignite your imagination with a speculative scenario that's bold yet plausible. It's year zero, day one. A faint hum pulses through the ground seismographs spike, gravimeters go wild. Scientists confirm, Earth is growing. Panic grips cities. Shanghai's skyscrapers sway. London's tube floods as land stretches. You, a nurse in snow polo, feel heavier each hour. Stairs becoming a slog. By day 7, oceans thin, fisheries collapse, and food riots erupt. You join a survivor commune in the Andes, where elevation eases gravity's pull. Submarine-inspired bunkers, with air recyclers from naval designs, become havens. In year 1, gravity up 5%. Sports shift weightlifters dominate, but runners falter. New rifts birth, volcanoes, their ash-fertilizing wastelands. By year 5, 25% heavier gravity reshapes humanity. Shorter, denser bodies, like ancient hominids, emerge. The moon frays into dazzling rings, lighting nights and inspiring new myths. You help rig salvaged satellite panels for power, while AI models, crunching petabytes, probe the core's frenzy. Perhaps a quantum phase shift adding mass from unseen dimensions. As particle physicists speculate on X by decade 2, double gravity crushes weaker cities. Oceans, steam, atmospheres thicken into a greenhouse inferno. Yet, equatorial launches send colonies to Mars, using new minerals for starships. Earth nears gas giant status, its core sparking fusion like a mini-star. Calculations hold. 8 petawatts, matching upgraded reactors, could shift orbits over eons. This isn't fantasy. Thermodynamics balances with smart alloys and optics fixing signal scatter or surges. Could we mine this Earth for interstellar leaps, signal aliens with gravity waves, or build a new civilization amid chaos? The dual-edge progress versus overreach demands. We rethink our cosmic role. What's your vision for surviving this new Earth? Share below. We've journeyed from a centimeter tick to a cosmic rebirth, using NASA's gravitational data, fusion insights, and seismic models to reveal Earth's fragility and humanity's resilience. What hit hardest, the lunar rings or crushing gravity? Could we thrive or escape? Drop your boldest ideas in the comments. Yours might spark our next epic dive. Smash subscribe for more universe-shaking explorations. Hit the bell for alerts and share with your crew. Keep dreaming big. The cosmos awaits your spark. Until next time, explore fearlessly.